Good morning, guys. Today we're going to look at solving quadratic equations by using the square root, or just finding square roots. So to solve or find the square roots, first off, it's only possible to do this if after we've combined all of our like terms, we only have one variable left. I can't have a square term and a linear term and be able to do square roots. It only works if there's only one variable remaining after we've done all of our combining of like terms. If it's not, then we have to go to another strategy, such as factoring and completing the square or quadratic formula. But this is when we have it all cancel out and you have one variable left and we can just get that variable by itself. So steps are isolate the squared factor, so move everything away that's not actually being squared. Then we take the square root of both sides to get rid of that square. And be careful, don't forget your plus or minus. Remember, if I take the square root of a number like the square root of 9, square root of 9 is not 9. Square root of 9, is not 3. It's actually plus or minus 3. Because positive 3 squared equals 9 and negative 3 squared is equal to 9. So anytime we take the square root, we've got to remember to put plus or minus on our solution. And then from there we just solve like normal. So we've got a few examples up here and let's go through it. So first thing, let's combine all our like terms together and see what we have. So 4x squared plus 3x equals 3x plus 48. So let's move these 3x's together. So I'm going to move this 3x over, subtract it over. 3x cancels. I get 4x squared equals 48. So after combining like terms, I have one variable remaining. It happens to be a square. So I just go through my steps. Isolate the squared factor. So I've got x squared. I need to get rid of that 4. That's on it. So we need to divide that 4 away. So I get x squared equals 12, and then we take the square root of both sides. Square root of both sides, x is equal to plus or minus. And you remember 12 is 4 times 3, square root of 4 is 2, so 2 square root of 3. Plus or minus. Remember, quadratics will always have two solutions. So the positive 2 square root of 3 is the solution to this. If I plugged it in, I would get these two sides equivalent. And negative 2 square root of 3 is also a solution. If I plugged it in for all the x's, I would get equivalent sides. Let's look at number 2. It's still a square roots problem, but it's presented in a little bit different manner because the x does not directly have a square on it. But let's look at it. If I want to start isolating my variable, moving things away from my variable, I'm first going to add my 4 over. 3 x plus 2 quantity squared equals sorry, let's just make this a plus 4. We'll make this a little bit neater of a problem. We won't get into complex numbers quite yet. So we'll subtract that 4 over. 19 minus 4 makes 15. Go through, keep isolating the squared factor. So divide by 3. So I get x squared, no I don't, I get x plus 2 quantity squared equals 5. Now you have to fight the urge right here to distribute that square. Remember, exponents cannot be distributed across addition or subtraction. Exponents are shorthand for multiplication, so they can only distribute across the multiplication and division. If I've got an exponent on a set of parentheses that has a plus or minus involved or inside of it, I'm finished. I can't do any more as far as trying to square that from a distributive standpoint. I actually have to write x plus 2 twice and multiply it out. Change it into a multiplication problem and not an exponent problem. But we're not going to do that because we can do square roots to get rid of that square. Same idea holds. I've isolated the squared factor. Now I can take the square root of both sides. So what that's going to give me is x plus 2 is equal to plus or minus square root of 5. Remember, don't forget your plus or minus. And then we solve like normal. Finish getting x by itself. Move the 2. X is equal to 2 and square root of 5 are not the same type of number. One has an exponent of 1, the other one has exponent of a half. That's what makes a radical. It's a different type of exponent. So since I can't combine them, I just write them both down. Remember in math, if I can't answer the question, what is this plus this, I don't try to answer it. I just write down this plus this. So that's my final solution. -2 plus or minus square root of 5. So this isolating of the squared factor can take on many forms. It can actually be a variable squared, or it can be an expression squared. But the same idea holds. When I try to get rid of that square, I take the square root of both sides, and I remember to put plus or minus on that other side. That's solving quadratic equations by factor square or by square roots, and I will see you in class tomorrow, guys.